It's Wednesday. That's the good news. Okay. So did we get through kind of talking through these yesterday? What's the first one do? Two things going on, right? There's a negative out here that does what? Okay, a little audience participation here, guys. What does a negative outside of the function do? Yes, up and down this way, right? Good job. X-axis, okay? And the +4 on the back? Shifts it up 4, shifts the whole thing up 4. B, what does the negative do inside? Yes. This one is on the outside again, so this is just reflect over X. Okay, reflect over Y would flip it that way. D, anybody? Yes, stretch 3 times vertically. Yes, 3 times as long that way. Absolute value on the outside can have no what? Negative X's or Y's? Y's. Y's. And F is just the function with a -5 on the back, which would just shift it down 5. Okay, now if we've gone through those, these should be pretty quick. Number 1, the parent is on the right. Can you tell what has happened? Yeah, I would say down. Let's see. Does it look like it went up to 2 and now it's down at -3? That looks like 5. So number 1 gets a big fat F for down 5. Number 2, here's the parent over here. Definitely looks upside down to me. Does it look upside down to you? But if I just flipped this upside down, it would, instead of going to +2, it would go to -2. Instead of going down to -12, it would go to +12. So I think it also was flipped and up, right? A reflected plus shift up. And it was reflected over X. Number 3. Oh, that one looks pretty obvious to me. Slanted. Yes, it is slanted on my picture. What else though? Look, it's now going way up here and way down here off the bottom. So it is stretched. Which one is a stretch vertically? D, yes. And we could, you know, it went up to 2 here, so now it's going up about to 6. Okay, it's 3 times as much. Number 4. Oh. No negative Y's. Which one was that? E, okay. And 5, ooh. Yes, it's reflected this way, right? Which one was that? Yep, the inside, the negative inside. And last one, I don't want to look at the choices. I want to see if I can figure out if this is the parent, -2 or +2, -12, +12. I think it's just upside down, isn't it? Reflected this way over X, which is C. Okay, I want to go quickly through these, but one of these you're going to need today. Midpoint. Oh my goodness. Just want to cry. How do you find midpoint? Why are these numbers so tiny? Can I make them much bigger so I can see? There we go. So the midpoint is you do what with the X's? Good job. And the Y's? 2 divided by 2 is, that's what I got. Anybody think that's okay? Okay. Did I do all right? 12 and 4 is 16, divided by 2 is 8, 5 and negative 3 is 2, divided by 2 is 1, right? We good? That was a negative 3 in there. Okay, distance is change squared plus change squared square rooted. Pythagorean theorem. What is the change between 12 and 4? 8 squared. The change from 5 to negative 3 is also 8, right? Well, it depends which way you went, but yeah. All that garbage. So 8 is 64 plus 64 is 128, which is 2 times 64. So what would that be? Square root of 2, square root of 64, which is 8 square root of 2. That's not on the homework today, but you vaguely remember that? Okay. This is the one you need to know. How do you find the line between those points? Silence. Come on, guys. What do you have to do first if you want the equation of the line that goes through those? Slope. So y minus y over x minus x is 8 over 8, or 1. Is that all it is? Yep. Okay, then what do we do with that? Now we have 2 points in a slope. Can we use one of those points? So y minus maybe 5, if I pick this as my point I want to use, equals 1, x minus 12. If I distribute and then add 5 over here, I have y equals x minus 7. To check that that works, on both of these, if you put the x in and subtract 7, do you get the y? 12 minus 7 is 5, 4 minus 7 is negative 3, it's working. Okay, yes, warm up done? Okay, worksheet. Okay, anybody need to borrow a pencil today? Because you're going to need to do pencil. All right, because we're going to do some erasing. Some of you are anyway. We're on 1.5B today. There's 2 separate 1.5 standards. 1.5B is piecewise functions. It says I can evaluate a piecewise. I can graph a piecewise. I can write an equation for a graph of a piecewise, and I can determine if it's continuous. All of those things eventually. All right, this is evaluating and determining if it's continuous. Evaluate each piecewise function. This one says h of x equals 2x plus 1 if x is less than or equal to 2, x squared minus 4 if x is greater than 2. So when I go to put a negative 1 in, you don't have this problem, just be hanging with me for a second here. If I put a negative 1 in, which rule do I follow? Top one or bottom one? Negative 1 is less than 2, right? Everybody good? Negative 1 is less than 2, so I'm on this rule. So 2 times negative 1 plus 1 would mean what? Negative 2 plus 1, anybody awake? Don't you get out a negative 1? Okay, so if we put in x equals negative 1, we got out a negative 1. What about x equals 4? Yeah, 4 is greater than 2, so we'd put the 4 down in here. 4 squared minus 4 would be 12. I'm going to write it this way. So h of 4 would become 12. Could have put here h of negative 1 was negative 1. Anyway, is this continuous? Okay, this is an issue on the quiz that students get wrong. It is continuous if at the rule change, they share the same point. Where is the rule change? What value? 2. So if I put a 2 in the top one, or I put a 2 in the bottom one, do I get out the same thing? Well, 2 times 2 plus 1 would be 5. So I put in a 2, got out a 5 for the top one. Now that had an or equal to, so at 2, 5, there's going to be a solid circle. If I put a 2 in the bottom one, okay, because it says greater than 2, I get 2 squared minus 4 is 0. So at 2, 0, there would be an open circle because I can't include it. It didn't have an or equal to line. But was it continuous? Did they match up? No, there's a jump at 2. So it's going to matter at the rule changes. That's the only place it can be discontinuous, is where it changes from one rule to the other. All right, the domain tells you which equation you use. This is the domain restriction over here. So if I put in a 0, guys, top one, bottom one, let's go quick. Less than 2, so I put a 0 in there, I get 2. Okay, put in a 2. Which rule? Bottom one, because it says greater than or equal to 2. So 2 times 2 plus 1 is 5. 4. Bottom one, 2 times 4 plus 1. Okay, is it continuous? What do we have to put in? Put a 2 into both, okay? If I put a 2 into the top, I get out 4. If I put a 2 into the bottom one, I get out what? 5. So did they match up? No. All right. Okay, this one, this crazy symbol is the round down or greatest integer function. Okay, this is a test. Do you know how to round down? Okay, -10, which rule? This is on the quiz. It's not on the homework, so beats between less than -6 is -10. So if I put a -10 in there, I add first and get -8. The absolute value makes it 8, but then I multiply by -3. So I get out -24. Is that okay to get out a negative? Yeah, because the absolute value was then multiplied by a negative, right? So it's always going to be negative unless it was 0. Okay, put in a 0. Which rule do I put that into? 0 falls between -6 and 12, so I put it in here. 0 minus 10. This does not make it positive. Does anybody remember what those do? Is -10 an integer? Yes, so does it round anywhere? No, the answer would just be -10. If I put a 2 in, it goes into the bottom rule, right? So 2 minus 10 would be -8. Is -8 an integer? Yeah, so I just get out -8. So it wasn't any fun examples. What if I put in a 4.5? That would go in the bottom rule, right? 4.5 minus 10 would be -5.5. And what is the rule for that? What's the next lower integer? -6. Picture your number line. You got to go further to the left. Yep. Is it continuous? Well, I'd have to put a -6 in up here. Somebody tell me what you'd get. If I put a -6 in up here, I'd get -4, but it would become +4, right? -12, okay. If I put a -6 in down here, I'd get -6 minus 12 would be -16. The integer would still be -16. So -6, -12 for the top rule, and -6, -16 for the bottom rule. Is it continuous? No. It is also not continuous after 12, right? It stops having a rule. All right, here we go. Graphing piecewise. You awake? Anybody want a ruler? There are rulers over the very corner against the wall in that bottom drawer, because you need to be halfway accurate on these. Here we go. The first one says, follow this rule for values less than -1. Is my graph paper separate? Good, I'm gonna make this big because I don't like it. Oh, yours is done for you? Is yours done for you on this one? Okay, so just listen to me talk through it real fast. 3x squared is a parabola whose vertex is at 0, 0, but as it goes over 1, it goes up 3 in either direction, so I would have this parabola. But I want the pieces of that parabola only where x is greater than -1, less than -1. I can read. That is a less than, guys. So I have to erase all of the parabola I just drew unless it is to the left of -1. Solid circle or open circle at -1? Open, because it does not include that. So if I put a -1 in here, I get out a 3. So at -1, 3, I should have had an open circle. And then if I put in a -2, I'd be clear up at 12, I think. So it's going quickly up that way. It doesn't look like a parabola, though, because it's so quick. What does this mean? It stays -1. That's going to be your favorite kind ever, guys. It's a horizontal line down here at -1. Where does that line go, though? From x equals -1, which is a solid circle here, yes? Okay, I got to erase all this. And then it goes till 4. What kind of a circle at 4, though? Yes, open circle, because it did not say or equal to. And then, oh my goodness, this is a what shape? Do you remember what shape that is? Who's his daddy? The parent function is a cubic, right? This is the cubic shape. But it has been shifted right 5 and up 2. And that means this little point would be at 5, 2. So over 5 and up 2. All right, but how else could I find some nice points? Put in values greater than 4, right? Including 4. So can someone put a 4 in? You could do it on your calculator if you graphed it. 4 minus 1, or 4 minus 5 is -1. Cubed is -1. Plus 2 would be 1. So at 4, it is at 1. Solid or open? Which means that's where it ends. It's not going to go down and meet up with this open circle down here. If I put in a 5, it's going to be at 2. I already know that. If I put in a 6, it's at 3. But if I put in a 7, high, right? 7 minus 2 minus 5 is 2. 2 cubed is 8. Plus 2 is 10. I think at 7, it's clear up here at 10. But that one should have an arrow because it says continue on past 4. Was that what it looked like? Did I do it right? Matching what's on there? I tried. All right. You don't have this one done. We're going to do this one. Ready? Okay. I know some of you have desperately fallen asleep. Now is the time to wake up. Pick up your pencil. Okay. X minus 5 for values less than or equal to 0. We could go down to -5. And what is the slope? 1. And graph that line. It would look like going up 1 over 1 like that. Okay, there's the line. But do I want that whole line? I only want what? The values less than 0. So which half of that line do I need to erase? Yes, everything to the right over here. So going less, this is the line. I'm good there. Do I make a solid circle or an open circle? Solid at what point? Yes, when I put in a 0, I get out a -5. So at 0, -5 right there, there should be a solid dot. Okay, then we switch over, and I'm going to switch colors just so you're clear on where this is coming from. But at 0, if I put a 0 in here, I get out 0. So at 0, 0, I have to put what? An open circle. Please don't leave off that and start at 1, okay? It goes right up to 0, 0. Now, if you want to keep moving to the right, because it goes until 2, so I would just quickly put in 0, 1, and 2, because it's only those points, into an x cubed. You get out 0, 1, and 8, right? When you cube them. So it goes through 1, 1, but at 2, it's all the way up to 8. Now it is curving. Yeah, should look like a curve. Anyway. And then starting at 2, what's happening? It was a solid circle at the top, right, at 2, 8. But now I have an open circle. Where does this one go? If I put a 2 in over there, I get, so I put a 2 in, I got out a 1. 2, 1 gets an open circle. Now, it's supposed to keep going to the right, guys. What is 2, 2? I'm sorry, 2. You guys are, okay, what have I done? We put in a 2. What goes past 2? The next number is 3, Hofbauer. That would be good. 3, so I'd have 2 over 3, or 2/3. Boy, this is hard to graph. If I went to 4, it would be down to 1/2. Does anybody know what that looks like? Yep. Because I'd have 2/4 or 1/2. It gets closer and closer. If you had typed into your calculator 2 over x, anytime you're confused about what shape you're supposed to be going for, put it in your calculator, but then remember, most of it's not there. If I go to y equals, and I get rid of all this stuff down here. What was this one? X cubed? No. 2 over x, yes? 2 over x. If I graph that, this is what I get. But remember, I only want points where? Yeah, so from 2 to the right. So if you were looking for ordered pairs, you could go to the table 2, 1, but then notice what happens. They're just getting closer and closer to 0 after that. That's most likely one I'm not going to put on a quiz. Let's try this one. I suppose I could be mean and put this one on a quiz. What 3 shapes are we talking about? Who are the daddy functions? X plus 6 squared is a parabola. 7 is a constant function, right? Just a horizontal line. And this is a V, possibly? Okay. Now, depending on the V, it could be cut off and just be a line. I'm just warning you ahead of time. And the parabola could be cut off and be part of one. But those are the shapes. Okay. What do you want to do here? This is a parabola that's shifted left 6. So it would be over here. So at -6, if I put in a -6, I get out a 0. But it wants values less than -5. So I could put in -5, -6, -7. I don't know which way you like doing these. If you like just using your transformation brain, or if you like plugging values in. But that's where the open circle is. You got to put it in to find where the open circle is. So if I put a -5 in, I add 6, I get 1 squared is 1. Put a -6 in, we get a 0. Put a -7 in, I get -1 squared, I'm back to 1. So it goes to the right to -5, 1 is an open circle. Then it's coming down here and going back up. Let's do one more point. What would -8 be? Plus 6 would be -2 squared would be 4. Could you be using your calculator to find those values? Absolutely. All right, then it says 7. What does that mean? So for the next piece, I'll use green. 7 is this line. And I want to keep it from where to where? -5, 7. Solid circle, yes. But then I keep going until 2, 7, solid or open? Okay, both of those had or equal to. Here and here meant that it was too solid on both ends. Okay, then we said we might be looking for a V shape. How could we find some points? I'll use blue. Well, what points do we want to put in? 2 and above, yes. I would put in 2 because that's going to be where the open circle is. 2, 3, 4. Let's try those. Put in a 2, I get out a, so that's an open circle at 2, 2. Put in a 3, what's 4 minus 3? So 3, 1. Put in a 4, I get out 0. I think it's going to just keep going down. It's not going to show a V because it's been, this is, if you wanted to think about transformations. Okay, does it? Let me think about this transformation. You guys are right. This is what has happened in my brain. That's how it became 4 minus x. So it was shifted to the right 4, but then reflected. So it was shifted to the right 4. My V was over here, and then it was reflected. Across. Okay. Yeah, just keep going. Put in a 5. Okay. It would, yeah. Put in a 5. We get out what? Put in a 6. We get out 2. So 5 is at 1, 6 is at 2. My graph is wrong. Yeah, I think the negative didn't matter because of the absolute value. Yeah. Anyway.
Well, either way, I think it would have been reflected and put over 4, then it would be still the same place.
Yes, because the first one was symmetric. You're absolutely right. Good call. All right. They're easier on the homework, I think. Well, not the book ones, but on the quiz, it's not as complicated. This is 4, which means a horizontal line up here at 4. Which part am I keeping? Everything to the left of -5. So -5 is here. Okay, what kind of a circle at -5? So at -5, 4, it should have been an open circle and going to the left. Okay, from -2 to 2, I'm doing a cubic. That's this shape, okay? You want to put them in real quick? You could put it in your calculator and find it, but cubing those will give you -8, -1, 0, 1, and 8. So -2, -8, solid on both ends, right? -1, -1, 0, 0, 1, 1, and 2, 8. I didn't switch colors. Is everybody okay? That's this piece. I can go back and do red for this piece if that makes you feel better. Okay, now what? Anybody know what shape this thing is? Square root is a half of a sideways parabola, looking like that. This one has been shifted where? Left 3, so it would have started over here. So it looked like this. So I don't think we're going to get all of that shape because we only want it beyond 3, right? That's disgusting because if I put in a 3, what do I get out? Yeah. I wanted it to be a 9, but it's a 6. A square root of 9 would have been nice. But I put in a 3. and I get out a square root of 6, and that should be an open circle. Well, I don't even know where that is. What is square root of 6? Between 2 and 3 somewhere, right? So 3 and up 2.4, there's an open circle. There was a gap, though, wasn't there? This rule ended at 2, and this one didn't start till 3? Okay, let's gotta make sure I didn't do something wrong. Now, if I put in a 4, I get square root of 7. That's not much nicer. Where does it finally hit something nice? If I put in a 6, then I'm up to 3. Oh my goodness. At 6, it's finally up to 3. Okay, so it's barely going up. It's going to look like a line, not a curve. Gross. All right, go back to worksheet 7A at the bottom real fast. We skipped this one yesterday. Does anyone remember what this looks like? This weird symbol? What is that graph as? Yeah, it's the step thing, okay? I know, don't cry. We'll get it. I won't put it on a quiz. I do hereby solemnly swear, okay? -1 is down here. Whoa. Okay, let me try that again. This. -1 is down here. Ooh, it's still in bed. But it only goes where? To the left of -3. Solid or open? Right up here? I don't know what's happening to my cursor. Okay, at -3 up here, I get out a -1, and then at -4, I'm still at -1. So -3, -1, and then it stays at -1. Okay, I can't draw straight for anything right now. The next one is from -2 to +2. If I wanted to do points, I could. What should it look like, though? What is x plus 1? It's a straight line, right? If I put in a -2, add 1, I get -1. So at -2, -1, what kind of circle? So there was a gap in there. And now it's open, and then what's it supposed to be doing? Yeah, the slope is 1, so it's just going up by 1 until it gets to 2. 2 plus 1 should be at 3. Solid or open at 2, 3. Solid because of this or equal to right here. Okay, then starting at 4. Does anybody remember what it is? Is 4 an integer? Yes, so at 4, it would stay at 4, but it would stay there all the way until 5, open circle, jump up to 5, stay there until 6. What are we supposed to include 6 though? Yes, so at 6, 6 it would have a dot. Okay, one more time. Raising my right hand, I do hereby solemnly swear there will not be a step function on the quiz, okay? They're very useful in real life because there's lots of things you have to round to a whole number. Like, if I was going to figure out how much paint I needed to buy, I would calculate the area, but then I would round it to a whole number. So at the end, you would put that symbol around it. Now, if it's buying paint, you would not round down, probably, you would round up. But there's lots of things that they round down to a whole number because you can't purchase part of one.
So you put that around so that you want to get the whole number?
Yes, yes. Except that one always rounds down. So if you were like programming something and you wanted it to be a whole number, you would probably have to put a +1 if you wanted it to round up, because then it would round down to the last number. That was confusing. That sentence just came out of my mouth and I was like, what did I just say? All right, guys, there's 4 book problems that you have to do tonight. There are graph paper in the back, but you should have also picked up the worksheet. Did you pick up the worksheet? Packet thing? Okay, I'm going to save these for warm-up tomorrow, but let's look at one of these crazy ones. Which one you want to do? We're going to do some more tomorrow, but let's do one today. You want to do one? Oh, I think we should stick with one. What do you think? They get kind of sloppy after one. Let's do this number 1 right now. This is on worksheet 8.5a. Not the packet. Everybody good? 8.5a? Should be behind 8.5 in your packet. We just snuck it in after we'd already numbered all the pages. Did you find it? This is in the notes packet. Sorry. You find it? 8.5 in the notes packet. Okay. Looks like this. Yes. All right. We're going to practice or try writing just one piecewise function today. I like to write the part back here first and get it out of the way because I think it's easier. What is this rule defined for? From here to here, what x values are that little piece down there, guys?
-5.
From -1 to 2, 3, 4, 5. -5, right? How do we write that?
If x is equal to 1.
When it's
If x is greater than or equal to -5.
Okay, we write it as a sandwich though. So we write from -5, which is less than or equal to x, up to -1. Why didn't I put a line under my or equal to the -1? Because it was open. Everybody good? We could write that rule at the same time because it's the easiest rule ever. What is that staying at that whole time? Y equals -2. Okay. I'm going to switch colors. This next rule works from what to what? From here to here, which would be from 1 to 4. And they're both solid, right? So we have 1 sandwiched with an x, sandwiched with a 4. You want to come back and figure out that equation in a second? Let's go on and do the green one over here. From here over, what x value is that one at? 4, but it's an open circle, so what do I write? Okay, if it has an arrow, I'm going to assume it has an arrow, then what is this? All of the values?
Greater than.
Yes, greater than 4. Or equal to? No, because it was open circle. And this one's an easy one again. The rule stays constant at 1, 2, 3, 4, 5. So that rule is just 5. So we need to figure out the rule along here. We practiced this earlier today. We need what? We need to find the equation of that line. It does look like the slope is up 2 and over 1. We could use that. The slope is 2. You might even be able to estimate the y-intercept. Some of you are just that smart. But otherwise, you can pick a point that's on it. Can I use 4, 2, or 3, 1, 2, 3, 2? I'm going to use the point 3, 2. I'm going to go y minus the y of my ordered pair equals the slope, x minus 3. I'm using point slope. Gives me y equals 2x minus 4. Did any of you think that might be where it was going to cross down here? If we had extended it, it would have crossed at -4, right? So it's 2x minus 4 is the rule if x is between those, and then this was the rule if x was greater than 4. So if you want to try some more stuff on that packet tonight, you can. Otherwise, just make sure you do these 4 book problems. There's graph paper in the back. You got to be accurate, guys. I don't want some willy-nilly sketch out of the back. It's gotta be accurate. A sketch, when I say out of the back, I was thinking out of the back of the book.
Also, where did that come from, willy-nilly?
I have no idea.